TSMC details its high-end 2 nanometers process, revealing massive performance and efficiency improvements. TSMC has revealed additional details about its 2 nanometers N2 technology, disclosing massive advancements in yield rates and performance metrics. TSMC's N2 nanosheet implementation has brought a huge rise in node performance, showing immense potential. The Taiwan giant's 2 nanometers process is one of the most anticipated developments in the market, mainly since the node is expected to bring in gigantic leaps in performance and efficiency results. The process is likely to come under mass production by H2 2025, and we now have information about the performance of 2 nanometers when stacked against previous gen counterparts, credit to the Taiwan giant's briefing at the IEEE International Electron Device Meeting, IED, in San Francisco, where 2 nanometers nanosheets were the highlight of the briefing. TSMC highlights that its 2 nanometers process has witnessed 15% higher performance, with up to 30% less power consumption, bringing in a significant rise in node efficiency. Moreover, the process has seen a 1.15 times rise in transistor density, credited to the use of all-around gate, GAA, nanosheet transistors and the N2 Nano Flex, which allows manufacturers to squeeze in different logic cells in a minimum area, optimizing the node's performance. By transitioning from traditional FinFET technology to a dedicated N2 nanosheet, TSMC has managed to bring greater control over the flow of current, which allows manufacturers to fine-tune parameters depending upon process use cases. This is possible simply because nanosheets have a stack of narrow silicon ribbons, each surrounded by a gate. This ultimately allows more precise control compared to FinFET implementation. TSMC's N2, by employing such methods, has brought a modest rise in capabilities, especially when you compare it up against 3 nanometers and its derivatives. This is why the 2 nanometers process is said to witness massive adoption from industry giants such as Apple and Nvidia, given the process's generational improvements. However, with such upgrades, TSMC's N2 process will also see a parallel rise in wafer prices, with costs soaring by more than 10% compared to 3 nanometers. It is said that an N2 wafer could range around $25,000 $30,000 per piece, depending upon how TSMC adjusts it, but this is a giant rise compared to 3 nanometers, which is said to be around $20,000. Not to mention that when you factor in initial yield rates and trial production, the end production would be a lot more confined, meaning that the adoption from the process will be slower at the start.